Hello there, welcome once again to our science lesson. And previously we have looked at inflammatory responses, and you can remember that these are biological responses of body tissues when the body tissues are exposed to harmful stimuli, which includes pathogens, irritants, and due to damage. We have found out that there are several steps that usually takes place during inflammatory responses. Now, just to catch up on what you learned in inflammatory responses, I want us to look at the following questions. So one of the question is, what is the first step in the inflammatory response? What is the first step in inflammatory response? First step in inflammatory response. So we said that once the body is exposed to harmful stimuli like pathogen, an irritant, an allergen, something that will cause allergic reaction, the cells or tissues have what you call receptors. Those receptors will recognize those molecules or the harmful stimuli, and in the process is going to release immune cells. These immune cells inclusive of phagocytes and macrophages, and also we shall have release of molecular mediators. We have found out those molecular mediators, what they are. We realized that there are three mainly: histamine, prostaglandins, and bradykinins. So in a nutshell, we are saying the first step is for the body tissues and cells to recognize the stimulus through their receptors, and in the process they release, or there'll be release of immune cells together with molecular mediators. So tissues and cells recognize harmful stimuli and they releases immune cells. In this case, the immune cells are the phagocytes and the macrophages together with molecular mediators. We can give examples of those molecular mediators, inclusive of histamine, bradykinins, and prostaglandins. So this is the first step, and then the rest of the reaction will follow. Most of the reaction will be due to molecular mediators, the histamine, the effect of histamine, the effect of bradykinins, and the effect of prostaglandins, together with the effect of phagocytes. So you can remember the effect of each one of these. Histamine, we said, histamine will initiate vasodilation and also increase permeability of the blood vessels, the arterioles and the capillaries. And then bradykinins, we said they will increase sensitivity of the nerve endings. So because of that, it is going to increase stimulation or increase the pain receptors, the ability of pain receptors to detect any pain. Prostaglandins will initiate formation of the clots. Question number 2. Why does the area swell and become red? Why does the inflamed area swell and become red? Why does the inflamed area swell and become red? Again, through our process, when we were outlining the process of inflammation, we mentioned that these are some of the symptoms: swelling and the tissues becoming red. For swelling, we said we have the mediator histamine. Histamine increases permeability of blood arterioles and blood capillaries, which will now allow leakage of blood proteins together with plasma, with the fluids or tissue fluid, which will cause the swelling of that area. And for it to become red, we said histamine initiates vasodilation. Vasodilation will now allow more blood to flow to the area. And remember, blood is red in color. So it becomes red, it becomes swollen. So for swelling, we said it becomes swollen because histamine increases permeability of blood capillaries, blood arterioles and capillaries, allowing. So we are going to have proteins, leakage of plasma proteins, and tissue fluids. Into the area. So because of this, there will be increase in volume of the tissues, thus the swelling. And for it to become red, becomes red because histamine again brings about, because histamine leads to vasodilation. Remember, vasodilation, that increase in the diameter of the blood capillaries, allowing more blood to flow, allows more blood to flow to the inflamed area. So as more blood flows to the area, it means the area becomes more red, because actually blood is red in color. Question 3. Why does the area become painful? Why does the inflamed area become painful? Again, this is what we were able to encounter in the procedure or in the process of inflammatory response. We said that one thing that happens, we have histamine increasing permeability of the blood capillaries. When permeability increases, more fluid, tissue fluid flows into the tissues, and then they become overstretched. So when they become overstretched, it's going to stimulate pain receptors. So increased permeability of blood vessels, of blood capillaries. Increased permeability of blood capillaries allows tissue fluid to flow into the tissues inflamed. The tissue is inflamed. So when the tissue is inflamed are overstretched, they are going to stimulate pain receptors. This overstretches the skin, and in the process stimulates, thereby stimulating pain receptors. So that is one scenario. Increase in permeability, more fluids flowing into the tissues, they become overstretched, and then stimulation of the pain receptors. But again, we said we have a mediator that is responsible for pain. That was bradykinin. So bradykinin increases sensitivity of sensory nerve endings. So when sensitivity of nerve endings is increased, any touch, any brush on that area will lead to pain. Becomes painful. So these are the two scenarios that will cause pain. Then the other question, number 4, question 4a. We have immune cells. So I want to define some of them. What are phagocytes? What are phagocytes? Now, for you to answer this question, you'll have to find out. Phagocytes, what are they? We know that they are cells. But what do they make? They make up components, or they are component of blood. Blood is made up of blood cells, the plasma, and several other structures. But phagocytes is a type of white blood cell. So having known that it's a white blood cell, we want to find out how does it now help, because we know that white blood cells are for the defense. They help in defense, or they destroy pathogens. But how do they do it? They usually engulf. And in the process, after engulfing the pathogens, they destroy the pathogens either by releasing lytic enzymes or through other means of digestion. So these are white blood cells. Are white blood cells. White blood cells which engulf and destroy pathogens and destroy pathogens. Now this term engulf, maybe you can look at it as we answer the question. One very important characteristic of phagocytes is that they are able to perform what you call a Moabite movement. A Moabite movement. So what is this movement? It's a movement that is associated with the movement that happens in amoeba. So for instance, if this is amoeba is here, we know that amoeba does not have a very defined shape like that. If it has to move, this is what will happen. It's going to extend the membrane. It extends part of the membrane. When it extends the membrane, we shall have cytoplasmic flow streaming. This cytoplasm that was here will now move in that extended portion. Those extended portions are called pseudopodia. So they extend the cell membrane, and then this fluid cytoplasm flows into the pseudopodia. So in the process, the pseudopodia increases in size. Pseudopodia has increased in size. But as it increases in size, the rest of the body parts reduces in size. So which means all the cytoplasm that was in that direction will have moved. So if you look at it, at the end of it, if all of the cytoplasm flows to that direction, it will have changed position. If it was somewhere here, it will have moved to a new position. So that is amoeboid movement. So it can use this amoeboid movement to engulf, to surround. Engulf simply means surround, and in the process form a food vacuole. When a food vacuole is formed, it's able to destroy. So it's moving by pseudopodia. Pseudopodia is made up of two words. We might also be able to know pseudo means false, and podia means feet. So it is moving by false feet. This is not actually a feet to help it move, but it's moving by extension of the membrane, cytoplasmic flow of the cytoplasm into those extensions, and then changing position. So how can it help? This is how it will help engulf. So if this is the phagocytes, and we have a particle there, a foreign particle, a pathogen. So what will happen in the end? This phagocyte will extend membrane. It will form membrane like that. It has extended this part and that part. So these are the pseudopodia. So in the end, that particle or the pathogen will be in that position. If it continues in that way, the two false feet, the pseudopodia, will now surround completely. It surrounds completely the particle. When it surrounds completely the particle, the two membranes at that point will fuse. The two membranes have fused. When they fuse, they form a vacuole. That vacuole is called a food vacuole. And the role of food vacuole is digestion. Digestion. So, for digestion to happen, we need enzymes. So it's going to release lytic enzymes. The food vacuole will release lytic enzymes. Those lytic enzymes will now destroy, if that was a pathogen, it's going to be destroyed through digestive activity of the lytic enzymes. So that is engulfing, surrounding, forming a food vacuole, and then destruction follows. So that was part B of the question, what is phagocytosis? What is phagocytosis? So again, once we have defined phagocyte, then it becomes very easy. Phagocytosis now becomes the process by which phagocyte will engulf, and then after engulfing, destroy the pathogen. So it simply becomes a process of engulfing and destruction of pathogen by the phagocytes. Is the process by which phagocytes will engulf. Phagocytes engulfs and destroys. And destroys pathogen. We have already gone through the process of engulfing and destruction, how that one happens through extension of the cell membrane of the phagocytes, forming a food vacuole around the pathogen or that foreign material, and in the process, release of enzymes which destroys the pathogen. Then C, explain why phagocytes and phagocytosis are needed in the inflammatory response. Explain why phagocytes and phagocytosis as a process is needed in inflammatory response. So again, we are just building on what we already know. The role of phagocytes and phagocytosis. Engulfing and destroying, invading bacteria or pathogens. And in the process, we were able to find out the outcome, formation of pus, that was one of them, and restoration of the tissues back to normal. But in this case, phagocytosis leads to formation of pus. Remember, formation of pus is due to presence of dead cells that were damaged, bacterial cells that invaded the tissues, and also the white blood cells themselves. If they die together, they form pus. So they are involved in engulfing and destroying, invading pathogens forming pus. This pus, we have said, contains dead cells. We had cells that were destroyed due to the effect of pathogens, dead cells, damaged or destroyed white blood cells, dead white blood cells, and together with, and now the pathogens, dead pathogens. Then the last question, question number 5. If our bodies were to be represented by a castle, if our bodies were to be represented by a castle, you answer the following question. Now, we know what a castle is. A castle is the home for the king, the queen. We call it a castle. So if our bodies were represented by a castle, you answer the following. What part of the castle would be the skin? What part of the castle would be the skin? So before I answer the question, maybe a description of the castle. A castle being a home of a king or a queen, you realize that it is well guarded. So you'll have maybe a very high wall. There'll be a wall. And then if there is a door, it will be a very strong burglar-proof door. There will be also windows for several purposes, for ventilation and also for vigilance, just for the watching if we have enemies approaching. And then we shall have high places on the castle where we are going to have soldiers placed at that point, so that they can watch if there is any danger coming. So we have a wall on this castle, we have windows on this castle. Remember, it is just built for purpose of protecting the king. A door that's very strong, burglar-proof, and then we have soldiers. We have the soldiers. That one describes a castle. So which part of the castle will represent the skin in our bodies? Remember, the skin, we have already gone through the skin, we have said, is the largest organ in our bodies. So the largest part of the castle, what you can always see whenever you see a castle, is the wall. So the part of the castle that will represent the skin would be the wall. And remember, some of the roles of the skin is to protect against invasion by pathogens. The skin is actually protecting us from getting those diseases. The wall is also performing the same in this case. So our answer there becomes the wall. And then, which cells of your body are the soldiers? Part B. Which cells of the body are these soldiers? So a castle has soldiers. for purpose of protecting the king, together with the queen. But now in our bodies, we also have cells that perform the role of soldiers, fighting. Soldiers are meant to fight any invading enemies. The invading enemies in our bodies are pathogens, bacteria. So the soldiers in our bodies are usually the white blood cells. Remember, we have different types of white blood cells that we have already mentioned. The phagocytes. Phagocytes, they fight physically. If they are the soldiers, they are the one that will be sent first, the ground soldiers. And then we have the macrophages. This one, they produce chemicals. Maybe those soldiers with different kind of techniques, like the Air Force, the macrophages, they produce the antibodies, which is the final onslaught on the pathogen. So phagocytes will engulf, use other means. If the pathogens are so strong that they cannot be fought or they cannot be destroyed by the phagocytes, the macrophages will now come in to produce antibodies. We have different types of antibodies. Then the last bit of that question is, how do these soldiers defend your body? How do these soldiers defend your body? We have just mentioned that if they are phagocytes, they'll fight through engulfing and destroying. If they are macrophages, they will release antibodies. Phagocytes, they fight pathogens by engulfing and destroying pathogens. Engulfing and destroying pathogens. If they are macrophages, this one produce special protein. They produce antibodies. Antibodies specific to pathogens. We are going to have a specific antibody against a specific pathogen. Antibodies are going to destroy pathogens in different ways. Some of them, they are antitoxins. Some of them are lytic. We are going to look at some of them. Then part D of that question. Suggest a feature that you could add to the castle. To the castle to show another barrier. To show another barrier. Another barrier to the entry of pathogens. Now, we have already described a castle in a very simple way. We have said it has walls, it has a door that is very strong, and then we have soldiers there watching very keenly, and then we have windows. So if we can describe this a castle as our body, we have the wall. We have already said that the wall is equivalent of the skin. And then we have the soldiers. Soldiers are equivalent of the white blood cells. Then we have this dough. That dough can be described, can be equated to a part of the body that takes in a lot of, it can remove and then take in a lot of substances, like mouth. Mouth will take in, and sometimes through vomiting it takes out, spitting. Then we have windows. Windows could be equivalent of the eyes. So they are already there, but you can add something on this. Now, let us look at the eyes. When an object, a foreign object, falls into the eye, something happens. We have looked at how the eye functions. The structure of the eye, we said, it has tear glands, and it produces tears. It produces tears. But there was one description very important for the tears. Tears, we said they are usually antiseptic. Antiseptic, which means they are able to kill pathogens. So in this, on this castle, we can add the windows are here, yes, equivalent of the eyes, but now we can just add, we can add there a structure to show that actually tears are flowing out. Tears are also antiseptic, so that if bacteria or pathogens are to get into the system through the eyes, they find tears there which are antiseptic. In the mouth, again, we have saliva. Saliva. So saliva also has the ability to kill pathogen. It's also antiseptic. So again, we can also add some lines there to show that the dough, we have something there. The mouth, we have saliva coming out to form even more barriers against entry of pathogens. So I think with those questions, you have understood very clearly how an inflammatory response happens. Now, inflammatory response does not happen on its own. It's part of very important response called immune response. Immune response. So what is this immune response? So we have immune system. We have a system called immune system, and it's the one that usually produces immune response. Inflammatory response is part of the immune response. So when you talk of immune response, this is simply activation of the immune system due to presence of a harmful stimuli, but not any other stimuli, but specifically a pathogen or an antigen. So immune response is the activation of immune system. Immune system. Activation of immune system by an antigen. By an antigen. So the activation of immune system by an antigen. So we have to find out the meaning of an antigen. An antigen is usually a foreign material that will now cause activation of the immune system. So you can define immune system in a reverse way. A foreign material or a protein material that usually activates immune system. So what is the component of immune system? Mainly in the body, the immune system is made up of the white blood cells. So it's the white blood cells together with the structures that produce white blood cells. For instance, the bone marrows. We have specific cells in the bone marrows called mast cells. Those mast cells are the ones that produce are the ones that produce antibodies and also produce very special cells like the macrophages and the rest components of immune system. So it's mainly made up of structures that produce immune cells. The major parts that produce immune cells are the bone marrow. So in the bone marrow, we have specific cells called mast. Specific cells called mast cells. And also some glands also produce the cells, glands. This one we can put here, glands. Glands. We have specific gland called thymus gland. Thymus gland produce the B lymphocytes. And then now the very senior ones, the white blood cells. But now we have to go back to antigens. What are these antigens? Then we shall find out how immune response happens. Antigens. What are antigens? So I think in my first part of immune response, or when we are explaining this, I've already gone through the meaning of that. So these are structures or substances that will activate, foreign materials that will activate the immune system. Are foreign material that activates immune system. E.g., examples of them include, we have been mentioning very many times, pathogens, pathogenic microorganisms, pathogenic microorganisms. So it should be remembered that not all microorganisms that are in our bodies are antigens. No, because we have some of microorganisms in our bodies that are important. They exist in a mutual way, in a symbiotic way, to bring about a balance in the population of other pathogenic microorganisms. So pathogenic microorganisms. And then these pathogens can also produce products of pathogenic microorganisms, pathogenic products. So what are these? For example, toxins. We have pathogens or microorganisms that usually produce toxins, and the immune response or the immune system responds to those toxins. Others that are antigens, we have substances that are called allergens. Allergens are the one that cause allergic reactions. In fact, allergic reaction is an example of an inflammatory response. Inflammatory response comes first, and then immune system will now come in later. Inflammatory response is unable to deal with the harmful stimuli in form of a pathogen or an antigen. So immune system will come in. Allergic reaction is an example of that. So allergens are those that causes allergic reactions. What is an example of an allergic reaction? For example, when you inhale, you are walking through a field of maize that is just tussling, and then you inhale the pollen grains. Pollen grains will be an example of an allergen. Pollen grains. So when you inhale these pollen grains, the body is going to respond. Immune response in form of an inflammatory reaction is going to respond through reflexes. Some of the reflexes include sneezing or coughing, just to expel those allergens. And then another example of antigen, also we have pathogenic, then we also have grafts. Grafts. So what's a graft? A graft is a part of the body, either from the same body or from another source, that is now transferred to or donated to another body. For example, we can have grafts in form of the cornea, the eye. We can have cornea of a sheep being placed into your eye, and it works. A graft of kidney. You can have, maybe if you have a problem with the urinary system, one of the kidneys has failed or both have failed, you can have kidney transplant. That is an example of a graft. We have several, even tissues. If one gets an accident and part of the body is ripped off so that that tissue no longer exists, was destroyed completely, we can obtain grafts from other animals, from other people, so that that tissue is filled or that place is filled. So that one can act as an antigen. Sometimes we have situation where a kidney has been transplanted from one person to another and is rejected. It was rejected because the body or the immune system recognized it as an antigen, a harmful substance to the body. So these are examples of antigens. But now, how does the immune system respond to antigens? There are two main ways: through production of phagocytes and also through production of macrophages. Macrophages are going to destroy the antigens by a process, by production of antibodies, but phagocytes by phagocytosis. We have already gone through those two. How does immune system respond to antigens? So we have found out the meaning of antigens. If they are introduced into the body, what is going to happen? So the body responds in two major ways: through production, increased production of phagocytes. We have known how phagocytes work. They engulf and destroy the pathogen. We have gone through the procedure of engulfing. And if phagocytes are not able to take care of the antigens, another mechanism comes in: production of macrophages. These macrophages will now release antibodies. Releases antibodies specific to pathogens or antigens. Specific to pathogens. there's something about macrophages. If, for example, the body has been attacked of a pathogen for the first time, macrophages will respond by producing these specific antibodies. But now there'll be a memory of that pathogen in the system of the macrophages. So they will evolve into a different kind of macrophages called memory cells. Memory cells. So they are macrophages, but they can remember the structure of the pathogen, such that if you are going to have any other attack any other time, the macrophages will remember that this is the pathogen that attacked this body at one time. And these are the antibodies that I produced. So because of the memory, is able now to release more of those antibodies to fight against those pathogens. This is a case, for instance, when you suffer from measles. If it is just once, the body is able to produce antibodies, but those antibodies will remain in memory cells in the form of macrophages. Any other attack of measles, the body will now remember, because the structure of the pathogen is within the macrophages. The body will remember and produce even more of the antibodies to fight against measles, and you cannot even develop the symptoms of the same measles. So we want to find out some types of antibodies as we move on and how they work. Types of antibodies. We have several. One, we have antitoxins. Antitoxins. Now, in our example of antigens, we have said we have the pathogenic microorganisms themselves and the products of pathogenic microorganisms. Some of the products are toxins. So antibodies, we have one type of antibodies called antitoxins. Antitoxins simply neutralize toxins. They react or they neutralize toxins produced by pathogens. So one way in which pathogens cause disease in our bodies, for instance, the Clostridium tetani, the one that causes tetanus, it releases toxins into the system. Antibodies called antitoxins will come in handy. They will release, they'll come in handy, and then they neutralize the toxins. So antitoxins are a type of antibody that neutralizes the toxins produced by pathogens. We also have antibodies called lysins. Lysins, you can realize this is a word coming from the word lysis. And lysis means to break. To break. The other meaning of lysis is to break. So lysins, being antibodies, they usually help the body or fight pathogens through destruction of cell walls and cell membrane of bacteria. They break cell walls and cell membrane of bacteria, destroy pathogens. By breaking down cell walls and cell membrane of bacteria. Now, in fact, from the mechanism of lysins as antibodies, several drugs have been developed that simply target cell wall and cell membrane of bacteria, such that now when the cell wall and cell membranes are broken, it will allow fluids, because bacteria in our bodies, it will allow fluid to flow into the bacteria, and in the process, the bacteria will either be destroyed through the fluids, because the fluids are increasing, the body or the structure of the bacteria is going to be destroyed because it is going to take in more of the fluids. And then the other one is agglutinins. Agglutinins. This is also an antibody from the word agglutination. Agglutination means coming together, clumping together. So agglutinins usually cause the pathogens to clump together. When pathogens clump together, there will be impairment in their reproduction, and also it becomes very easy for phagocytes to destroy them. So causes clumping together of pathogens. So when they clump together, it's going to impair their reproduction. Remember, most of the pathogens that cause diseases are mainly bacteria. And bacteria reproduce through binary fission. Binary fission, one bacterial cell divides into two bacterial cells progressively to two in that form, and the procedure continues to make many of the bacterial cells. But now there is clumping together of the bacterial pathogens. So what will happen? Their reproduction is going to be impaired. This impairs reproduction. And at the same time, when they are clumped together like that, it becomes very easy for phagocytes to destroy them. And phagocytes easily destroys them, easily engulfs, them. And then the last, or the fourth type of antibody is opsinins. Another type of antibody, fourth one, opsinins. Now, opsinins, before maybe I do a literature on the same, opsinins, if this is the pathogen, opsinin will adhere on the surface of the pathogen. When it adheres on the surface of the pathogen, it's going to interfere with the normal functioning of this pathogen. So it adheres on the surface of the pathogens. So in the process, interferes with functioning of the pathogen. So as we get to that point, we shall also be looking at the type of immunity or immune response. We have two types of them. We have the innate immune response and the adaptive immune response, which we shall be looking at it at our later lesson, types of immune response. So we have two of them. I'm outlining this so that at your own time you can look at it through the internet and in your library. So we have innate immune response, and adaptive immune response. So at your own time when you are free, you can look at the two types of immune response. So I hope you have gotten everything that you have gone through. If you have questions, we shall tackle them in our next lesson when we shall be looking at these two and also summarizing using the questions. So welcome already to our next lesson in maybe in 1 or 2 days.